Good morning, good afternoon, good evening, everyone. Welcome in Learn Grasshopper live series. We are coming back with our series after vacation. So good to see all of you. Hello, Mario. Hello, Mikael. Can you hear me?
Yes, hear very well.
Perfect. Where are you both based? I'm based in Gdańsk in Poland, and you?
Based in London?
I am in Milan, Italy.
Nice. So already after vacations and already 100% steam on your project?
Yeah, it's September is a kind of difficult month, but it's good to be back as well to do something useful.
And nice to see you online, but we met already in London this year on the Shape to Fabrication. So good to see you here, and thanks for accepting my invitation. We have already some people watching, so please let us know if you can hear us and see us. So we will start just in 2 seconds. Mauro, and Mikael, please tell me a little bit your background. As far as I know, you've been working as architects. Where have you been working before doing your own business?
Yeah, we both have architectural background. Both graduated in Italy. We studied in Italy architecture, and with Mikael we met a few years ago. Now it's almost 10 years ago in a very popular practice, Hadid Architects. I personally been working on with Perkins+Will, and then at Hadid Architects. Mikael?
Yeah, so as Mauro was saying, we met in Hadid, and then I moved to Foster and Partners for many years. Mauro and I, if I can speak for both of us, we've been architects, designers, but very interested in computational design and also BIM. Hence, our interest in those two universes and like put them together. So we have been specialists in advanced parametric modeling and BIM. So we were BIM coordinators and BIM managers of complex projects like airports, stations, huge towers. And we used our scripting knowledge to produce geometry and inform geometry in terms of like BIM objects and healthy BIM models from super complicated designs, like Zaha did it and Foster as well. And during the years, we developed a lot of interest in the development side of things. No, Mauro.
Yeah.
Amazing. You work. It sounds like you work on the amazing project in the really great companies, and now you have your own business, and now trying from the different side, helping all the architects and designers with making great tools like a BIM or Rhino thing that you are going to show, I hope, and also a connection with Revit. So let's start. Lots of people here. Hello, Alexander. Hello, Leonardo. Hello, Andrea. Everything's working, so let's start it. So we are live on LinkedIn, we are live on YouTube and Facebook. So if you're watching us there, so please give a like. For sure, it will help me to reach more interested people in new ways of working with Grasshopper. We are continuing our series. We are going to talk also during this 2 days workshop about Revit. And so that's why we landed in the Revit series. All the episodes from the previous can be watched on our YouTube channel. All the learning materials are still available. So you can just go to the same links and you can download all the recordings and learning materials. Plan for today workshop, we try to present all the work that guys are doing in one webinar, but I found it like lots of knowledge packed in one webinar. So that's why we try to divide it. So first day, so today we are going to talk more about managing IFC, more about assigning the data beam, automative everything, like how we can automate it with Grasshopper. And then tomorrow, at the same time, we are going to talk more about connecting that with Revit, because the tools that can be used for both and how we can actually deliver clean IFC models in Revit and also geometry. So really looking forward to this workshop. So today, we have like slot. I booked guys for 2 hours, but let's say that we have 1.5 hours with all your questions. I think 1 hour presentation will be okay, and then rest will be for questions. Recordings will be available to watch later. It will be available for everyone who will register. learngrasshopper.com/Revit/BIM, and BIM not like a BIM, but BIM like a software that we are going to present today. We are going to share all the Grasshopper and Rhino files that will be presented, so don't worry, you will have time. Michael is really fast at creating scripts. I know that because I've seen Mikael, some of your webinars, so it will be hard maybe to follow you along, but no worries, we are going to have the recording so you can do it on your own. And this is if you are creating tools. So for how many years you've been creating the tool, Mikael?
So I think we started this project in about 2019, BIM. So it has been a while, it's been out with a lot of iterations, and is reaching a nice maturity. Actually, today we will ask you guys to use the beta version, but it's very stable, will be released very soon as well. So a lot of new features as well to showcase today as a first, let's say.
Perfect.
Great try.
Great opportunity to be first beta testers. And as always, if you have any questions, just write it in the comments. We are here to help you and guide you. So for those who are seeing me for the first time, my name is Krzysztof Wojsław. You can call me just Chris. I'm an online educator. I've been working as a structure engineer for 10 years, and 3 years ago I decided to go full on the online business, and now I am 100% on the YouTube and doing my educational platform, helping architects and engineers to learn programming, to have more fun at their work. We are also introducing Grasshopper at the universities. I'm glad to see more and more universities joining, so we can introduce Grasshopper already on architecture and engineering studies. But today topics, we are going to talk first about managing IFC in Rhino. So for those who were not believing that Rhino can be used for BIM, they've been wrong, because you can import and export IFC, of course, with some plugins. And today, Mauro and Mikael are going to present the work that they've been doing for, as you said, 6 years already on the market. So I'm really glad to see you, Mauro. The stage is yours. So now we can see your presentation. So yeah, so you are working, so your company is called MKS DTech, right?
Yes, correct. So yeah, I mean, first of all, thank you, Chris, for organizing this. We are really excited about this webinar. And yeah, as you mentioned today, we're gonna talk more like generally about IFC. So actually, IFC has been a big request for BIM, and it's a fairly recent addition to the features that we have in BIM. But generally speaking, BIM. So with BIM, we try to add a layer of information to Rhino, because we love Rhino. It's an amazing tool for modeling. But what we feel it's like it lacks a little bit of BIM capabilities. That's why we put together BIM to add some layers of information to the objects in Rhino, and eventually export, import in IFC. So today we're going to show all of this, managing the data, import and export. So yes, but a little bit more about MKS DTech. What we like to do is to try to bring back time to the design. So there is a lot of efforts in the AC industry to make things happen, like workflows and complex workflows. And what we try to do with the MKS DTech is to try to simplify these workflows for the industry, and to save time for the architects so they can spend more time on design.
And I can believe this statement for those who've been working as architects for their whole day life. So you really made that statement that you really want to, you really know what architects are the biggest pains.
Yeah, those were our pains back in the day, so we kind of I can relate very, very strongly with this.
So you have all the bad memories after that.
Exactly. No, but that's exactly as you said at the beginning. All of everything that you are going to see, it's because of our background of architects. So we are using those workflows that we used to do ourselves in the first place, and then try to create tools to embed this intelligence that we have acquired during the years. And yeah, so as I mentioned before, Rhino is a very powerful modeling tool, but it lacks BIM functionalities in our opinion. And so our goal is to adding BIM data to structure this data, and also adding something that is super important for us, which is the collaboration. And the collaboration comes in two shapes. One is to include the IFC workflow. So being able to speak with your consultants regardless of the disciplines, so architecture, importing MEP models, working with the structure, and so on. And another part of the collaboration, which is the part of Rhino Sync, that we are going to show a few slides, and hopefully that it's really exciting for you as well. So BIM, let's say the core of BIM is adding the metadata to the data and properties to the objects. And we do this through this BIM panel that we have in Rhino. And most of the work that we do in the workflows of IFC or exporting to Revit, or when we import IFC, is through the BIM panel. And we try to make it as simple as possible, but you can visualize and managing the data through the panel. And Mikael will going to show you this in detail. So we are really happy about the reach of BIM. So at the moment we've been working with the biggest and most popular practices, architectural practices in the world. So we are working with the Snoetta, Big, Edenwick, Foster & Partners, and so on. So they are all BIM adopters, and actually it's great to work with these studios because they can communicate to us some. They can request features, and we are also, day to day evaluating the workflows, and we can, through this collaboration, we can enhance BIM and improve BIM day by day. And as you can see also, the BIM uses all across the globe. So just a few technical and compatibility aspects. So BIM is available for Rhino 7 and 8. And also available for Revit from 2018 to 2026. 2026 has been included just in the last few weeks. And when it comes to IFC, we are compatible for import and export with IFC 2 and 3 and IFC 4. For this special occasion of the webinar, it would be great if if the audience can use these credentials, so they can access the full potential of BIM and have no limitation in objects or whatsoever. And these are the credentials. So I think you guys might want to take a screenshot or copy this credential. I think we can even copy this in the chat.
Yeah, I will add it in the chat. So a good thing. And thanks for that. It's really great for community.
Yeah, and another thing, Chris, if you could also copy the beta version that I copy in our chat. So and distribute
on the GitHub.
Yeah, exactly that one.
Mm-hmm. Yeah, that's important because today we'll be showcasing some features that will be available in the release that is coming probably next week, or the one after we finish the final testings. But just to have on par version, that will be the version we'll be using today.
Yeah, and so that's why. So it's great to take this opportunity to showcase these new features. So Chris, you should consider yourself very, very lucky about this.
Yeah. Thanks for. I didn't expect that. So thanks for this gift. So it's like a Santa Claus come earlier, not in December, but in September.
That's good. So and also before moving into the demo, we want to give a little, we want to show a little bit more about our latest product, Rhino Sync. Some of you were present at the Shape to Publication, we announced this this tool, this new workflow at the beginning of the year, and with Rhino Sync, we want to make the Rhino user able to collaborate in the same file. So to enhance the collaboration with Rhino, and this is a feature that we feel it's missing at the moment, and can enhance really the collaboration between the different users in the same file. They can, as you can see from the screen, you can visualize all the users that are collaborating in the same Rhino session. They can chat with each other. So we are trying to include this feature, and now it's an alpha version, and hopefully before the end of the year we're going to release the official version of Rhino Sync.
What is the feedback so far? Have the architects been using Rhino Sync?
Yeah, there
were some early adopters, and we call it alpha just because we want to be very conservative, but it's quite effectively working. Most of the objects and elements from Rhino are synchronized now, so geometry, blocks, materials, like all the good stuff that you need really for designing, and it seems to be very stable. So give it a go. We want to see bigger teams or more complicated models to be used on it, so we can improve it and make it even more effective. But in the end, it works really very similar to how Revit works.
Yeah, exactly.
Someone like the visuals. We are big time retro people, so we want our, just as a fun fact, the inspiration is a Winamp media player. If you use that.
Yeah, I was about to say that if you can play music, we have also Felipe who said that there's a nice visuals, and I agree. And all my memories, all my playlists from my childhood just came back.
Yeah. We do everything ourselves, so from the graphics to the software, but we really like to manage to work on the graphics as well. And yeah, so Rhino Sync, as I said, now alpha version is out. It's completely free, so just reach out or go to mksdtech.com sync to download the version, which is very importantly compatible only with Rhino 8 right at the moment.
Mm-hmm.
And that's it. I think I can just leave it to Mikael.
Okay, well, thank
perfect.
You,
I can.
We'll take over.
Mikael, yeah, if you can just share your screen so we can go to presentation and see the way. Let's go and jump into Rhino and see how we can generate IFC from this file.
Yes, so as you can see, I have Rhino open and I have my beam panel visible. So as you install beam, the beam panel might be hidden in the layers and other two utilities tabs. If you cannot find the panel, always you can go to the option wheel, press show panels, and then beam will be the first one probably because it's in alphabetical order, but you just click it and it will appear. You can also click on an empty space on the tab here and just be able to show it. So the panel has a few parts, composed of a few parts. We have our version, so you can check the version. Also, this new version has a hint of the version here. We are talking about 1.13. You might have it still in beta form, so you get the notification for update when the full release is on. So I hope there are no huge bugs happening today. They might happen, so don't be scared. They will be all ironed out before the final release, but it's fairly stable and has a few new features that we want to showcase today. So please download the beta version and especially log in with the credentials that we gave you, so you can remove any limits for import-export functionality, since with the free version, you can export just a limited set of elements. So with that, you will have a license to use full features. We will ignore a few of these buttons that are more related to the Revit workflow. And in this part, we have a few utilities for finding families in the model, creating parameters, scheduling. This is a new feature that we'll show today for this new version, managing levels in the file, and so on. And then a few buttons for exporting and importing data, including the IFC settings of the file. We will see them one by one as we go through. So before moving to Grasshopper, we will use Beam in the UI form, because that might be still a convenient way to associate data. So many times it's just easier just to point and click at things. But most of the features that you will see here, if not all, are also available in Grasshopper. So we will do the same activities in Grasshopper later on. But it's important to see how you can access this data and use this data in Rhino. So the idea, as Mauro was mentioning before, is that we want to beamify Rhino. So we want Rhino to be able to classify objects, add attributes, but not only in the form of simple user text that is already available in Rhino, but in a way that parameters are parameters. Maybe they're associated with categories that are fixed set of parameters you can choose. So free text has the issue that you could make typos or mistakes, so it might not be super convenient. So with Beam, we add this layer of predictable data manipulation and access that is saved in the Rhino file. So anyone that has Beam installed can access this data. It's actually free. You don't need a license to do so. So if you add metadata, you create parameters, create objects, all of that is saved in Rhino file. Anyone can access, consume them, modify them, save the 3DM. So all of that is, let's say, the base, the core of Beam is free and is completely available. We want to push Rhino to have these capabilities. And you might need the license only when you are actually exchanging data with other platforms, like, for example, Revit or a big IFC export. But all the data manipulation for Rhino is completely free, and you can use it with no limits. We want to use this into data.
So import and manipulation of all the parameters, but also export, or export now is not included.
Export, you might require a license to do so, but everything else it's free. So here I have a piece of geometry that we will use as an example of how to create an object. So it's kind of a free-form kind of piece of information. And as you can see, as I click, the panel will start, proposing what information I can modify. So first, I have the family, which will be a component or an IFC product. So it's basically a way to group objects into one item that is going to be part of the IFC or the Revit export. So I can start typing a name here, but we'll see that later. Subcategory is related to Revit, so we will exclude now. And then we have the material. As you can see now, the material is blank because there is no Rhino material assigned to this object. So this is not another material parameter, it's the material coming from Rhino. So if I assign this parameter from a layer, for example, here I have changed that. So if I change this to be material, actually here, if I say use layer material, you can see now the layer material brass is assigned and it's the same in the Beam panel. Okay, so if I assign it either by object or by layer, the Beam panel will show this parameter. However, the Beam panel also allows you to change very quickly in a more convenient way, we believe, than going to the material tab, but that's debatable, up to you. So I can change it to aluminum, or I can change this to glass. So it's quite easy to change the material from the Beam panel. Be aware that when you change it from here, you might switch from by layer to by object. So be aware of that if that's what you're after. There's also a possibility to type a name here. When I press enter, new material is now inserted, and in my materials tab, I can see new material here, and I can edit the appearance. So it's a quick way as well to create a new material just by typing a name in the Beam panel. Okay, so let's go back to brass. So I'll assign this as a brass material. I will take this piece of cladding here and say this is actually my glass. Okay, and maybe I will leave these in aluminum. Okay, so I have assigned some materials to these objects just so we have some materials. Next, I will select the objects, and actually I will start. There are some curves, I think. Let's just remove this curve. So select the objects. Okay, and then I will type module, because this is my component named module. And now I have created a family in the document. there are two different ways of creating families. One is as we see now, so by selecting loose geometry, so geometry that is not inside blocks, and assigning a family name. Otherwise, I can create a block, and the block will be automatically a family, and we will do that as well. But now, just for the sake of this presentation, in this moment, I will use loose geometry. Be aware there will be only one instance of this family. If you require to have more instances of the same family, you might want to create a block. We will create a block later of this geometry. But let's take the simplest case. So I have my module family. I have assigned different materials. And as you can see now, I have more properties associated with the family that I can assign. One, and maybe one of the most important, is the family category. And these will be Revit categories, because that's the kind of the standard workflow for BIM. So you can choose a list of families from Revit that in the Revit workflow will be used to create the family category. So I can pick any other one. I can pick columns. I can pick maybe floors or furniture and so on. Okay. Then on the bottom, I have some IFC data. And in this IFC data, I have a few more things related to IFC that I can change. So first of all, the type, and by default is set to automatic. What does it mean? So you guys know that IFC has a lot of types. So IFC railing, IFC chimney, IFC column, etc. So by default, when you choose this kind of simplified Revit categories, we have a default mapping that will map them to IFC categories. What this mapping is, so if we go to the panel in the Get Help section, this will bring up the wiki page. Let me just scale it down a bit better for you. So you go to the wiki page, then we go to BIM IFC for Rhino, and then we go to IFC type mapping, and we can see here all the mapping that we have done for the objects. Okay, there's a type here, but this is IFC wall. So you see roofs is IFC roof, columns IFC columns, IFC slab, and so on. But you don't have to use those necessarily, and at any point you can change these to any type that you want. So for example, I will change these to IFC door. Okay, now it will make sense because we're talking about furniture, but let's say that this is a generic model, but here I want to have actually a IFC covering. And then by choosing these will be ignored when exporting IFC, and only this type will be used. Next, this unlocks also the possibility to set a predefined type, which is like a subcategory in IFC. So for example, I can say this is cladding. Okay, so when exporting this to IFC, it will be exported as an IFC covering element named module in the predefined type cladding subcategory, let's say. Okay. Another thing I can do, I can add a description. It is a specific IFC parameter. So it's not part of the family parameters, but we add it into the description. So I can say this is my cladding module. I don't know. Okay, so we can add any description. And then new in 1.13, we can also assign it a level. We'll discuss this when we cover levels. Okay, but now just focus on the category. So this is the Revit category. Then we have our type override for IFC. It can be in automatic using the mapping I showed you, or you could choose any of the available IFC types that we propose here. These are all of them, or almost all of them. There are some maybe MEP ones that are new that are in some IFC 4.2 versioning, so we will add them as they become more stable. And then you can also check a predefined type. You can also say undefined if you don't want to have anyone. Now I cannot find it anymore. You can use maybe user define and so on. I'm not defined it, so you can also ignore this setting. Okay, so this is for categories and types. I hope everything is clear. Just let us know in the comments, or maybe please stop me if I'm going too fast. Another thing
that's make really nice sense to all the IFC types and descriptions. So it's really easy to change and navigate.
Yes. Okay. So this is also collapsible, just to make it easier. Then we go to a part that is very important: parameters. Okay. So there are different types of parameters in BIM. By default, both in instance and type parameters. So instance parameters are available or are specific to an instance of a family, while a type parameter is the same for all the instances, right? In this case, we have loose geometry, so there is only one instance of this family in the file. But for example, if I create, now this will not be the best design, but if I create a block, okay, with an insertion point, and I will call this, well, block 1. As you can see, in BIM, the block name is automatically the family name, okay? Then I can change also the category and the FC data as for the loose geometry family. But I don't have access to the material subcategory and everything, because of course I have to enter block edit mode. And when I click on the object, I have access to this subcategory material and data. So if I want to change the material, I can do so from here, okay? Press OK, and now I have my block 1 family, which is a generic model. So just let me create a copy of this and demonstrate these type and instance parameters. So if I change a type parameter, for example, the keynote, say H100, and I click on the other block, you will have the same keynote value because it's a type parameter, so it's common for all the instances. However, the comments is an instance parameter, so each block might have its own instance parameter. So as I click, they will have different values, and this is very important in many instances. Of course, no pun intended. So you just to clarify, we can have loose geometry, and in that we have access, of course, to the inner properties, and we have only one instance of module family. While for block 01 family, we have 2 instances. Each one will have their own set of parameters, but type parameters in common. By default, BIM has 3 instance parameters: comments, mark, and work set. And in type, keynote and type mark. So these are built-in parameters, will always be available. They are very common, especially in the Revit world. They are important and the most used. But we are not limited just to these parameters, and especially the property set. You can see default is our property set that is default when you open BIM. But we can customize all of this. How to customize these parameters? So using the P button, okay, we can access our management of parameters in the file. And this is where it starts to be more convenient than using user text, because we have a centralized way to control and manage parameters in the file, and we have a bit more of information about the parameters. They're not just text, they have different types, and we'll see that now. So we see all the default parameters, so these are not, you cannot remove them, so they're built in the file. But let's create a new parameter. So we click on add, and we can say here new parameter. Okay, we can choose whether it's an instance or a type parameter. Let's make it an instance. Then we can define the data type of the parameter, and it can be angle, area, number, text, volume, all of these available to you. Okay, so each one will have also different behavior in the panel, in the association. So when you have text, you can put any value, but of course, if you put area, only numbers will be available, and they will be associated with the units of your file. So my file now is in millimeters, so the area will be in square millimeters. Okay, let's make it actually an area. Then we have a property set. We just have default now, so we will change that in a second. And then this is also very important and convenient. We can define which categories will show this parameter. So if we want all the categories to show this parameter in the panel or have it associated, we check all of them. But maybe we just want this to appear for furniture. So this is a parameter specific for furniture and for furniture systems. So we can filter out certain categories from having the parameter available, and that makes it convenient, so you don't have parameters that are unrelated to what we're doing showing in the panel. So let's make it available for all the categories, just so it's easier to track. And then we can press OK, and we see now my new parameter is added to my file. Press OK again, and when I go to my object, I can see new parameter is added, and because it's an area value, it's in square millimeters. Okay, so I cannot type text, for example. So this extra control, it's what makes it easier to work with the file compared to maybe user text, where anything is possible. Okay, so another thing I can do, I can start creating more parameters, and also grouping them in property sets. What is a property set? Property set is like a container of parameters, so we can easily group them and maybe turn them off or on, and classify them under a specific schema or grouping that makes sense for them. For example, I can go on property sets here, and I will add a few property sets. Of course, default is always available if you don't have any in your file. So I'll just add maybe a custom. Okay, sometimes you might want to add the Pset custom. Depending on the IFC interchange that you're doing and the parties involved, you might have specific rules on how to name the parameters and property sets. We will ignore this here and just go with convenient naming, but you might want to use whatever is required by the BEP or any other documentation. So let's use custom. Maybe add another one called data. Okay. So by doing so, we can create a new parameter. Let's say information, and we make it a text, also available to all of them. Let's also make is included parameter. Let's also use a space, not important. Although it might not be in IFC, you might want to have no spaces. Let's make it a ball, for example, yes or no, and available for all of them. So I have a lot of now new parameters of different types. Instance, maybe this. Let's make it type. Okay. And now I'll pick those parameters and start adding them to property sets. So for example, new parameter would be in custom, maybe is included, will be in data, and information as well will be in data. Okay. Now when I press OK and I click, you can see now the panel starts to be populated with a few more parameters and property sets that we can also collapse. Okay, so we can collapse. So we have now a new parameter, which we can put like 200 maybe, information, learn Grasshopper. School.
And speaking about Grasshopper, do you have also possibility to create all these properties through Grasshopper, or you have to do through Rhino?
Absolutely, absolutely. So we will show that in a moment. So now I have my information, learn Grasshopper School, and then under type we have our is included and so on. And another interesting thing about the panel that maybe you don't know, that you can actually restore, change the length here if in case maybe a parameter is very long. So now I have assign a few parameters to the objects. Maybe I can also add a type mark, and then one. We have maybe let's change the IFC data to IFC pile, change it to driven, and so on. Okay, so now we have created a lot of parameters with property sets, different data types. We change the category and the type and predefined type, and so on. And this is starting to look a little bit more of a complete data set. Let's see something else we can do also. Let's work with levels. Okay, so let me just make this fly a little bit more. Okay, let me just measure very quickly how much is this we can create. So 6,000, perfect. So another thing we can do, we can create levels. So to create levels, we go to our levels interface, and there is always a level 0 millimeters. So you must have at least one level in your file. By default will be height 0. But we can create more. For example, we create a level 1 at 6,000 millimeters. Okay, that should be okay enough. Okay, so now I have two levels. And when I click on an object, so if it's a loose geometry, we also have this, and so the level will be associated with the family, but also blocks. Each instance will have its own level assignment. So if I keep it as automatic, the bounding box of the geometry or the insertion point of the block, which I can change here to align to object. Okay, so this insertion point of the block, this will be used to find the closest level below automatically. But we can also override it and say this is level 0 and then this is level 1. Perfect. Okay, so now once this is done, we can just select everything. I will just show the UI as Chris before we move to Grasshopper and start doing some automation there. So we can.
And I really like in the menu that you don't have to confirm every time you would like to change. And I really like it. It speeds up a lot of things. That if you would like to change the type, just click it without clicking OK and apply and so on.
Exactly. Before exporting, actually, let's check something. So this is a new feature, and we'll just cover it briefly now. But I think it's a very cool addition that we have. You have all this data. How you consume this data. You can extract in Grasshopper, maybe But you can also query the data. Actually, there's a few other things to talk about. For example, in the P, and this is UI only, of course, but that's fine. You can export all these parameters into a JSON file. Let me open a new Rhino just to prove. So you can export these files and say, this is my IFC parameters. Okay, so this now is saved in JSON format. So we like JSON because everybody can open it. So let's open it with Visual Studio Code. Of course, you need to change just to format the document. And as you can see, all the parameters that I have created, Beam, the categories associated them, the instances, etc., are added in this file. You can also manually generate this file. To create a list of parameters to import, you just have to follow the schema. Okay, so you just export manually. See, you have to have the name, its instance type, property, all of these the same way. And we can use these to export, import parameter sets to new files. So maybe you always have your template document and you have a blank new file. You can see there is no parameters here, but if I go to import, now it's completed and I have the exact same parameters import. So it's easy to just create a template. In this case, of course, if you save the Rhino file, these parameters will be saved in the Rhino file, but in case you want to add them to another file, you can export them and add them, so you don't have to go through the process all of the time. And if you prefer, you can also modify this file rather than using the UI and create the parameters, or use Grasshopper. So you have many ways to create parameters. Yes, Chris?
Or you can also use ChatGPT, which is amazing with editing JSON file. If you are not familiar with JSON file and you don't know what are these exclamation marks and parentheses means, so you can just copy to ChatGPT and just ask it which parameters you would like to edit. So it's also a great way. In the between, there is one question from Ted I would like to ask you. Hello, is it also possible to load a custom proper sets text file like in Rhino, like in Revit?
Yes, we can. If you have share parameter file from Revit, you can also import that, and I'll show that in a minute. So in the import, it's good that you asked this question, Ted, because it might be hidden. You can change the type here, and if you go to text file, you can actually let me just speak from my drive. We have some in the demo. So we have a share parameter file here, and in this case, you can pick from the share parameter file or the parameter you want to add. Okay, or as Chris was saying, give the share parameter file to ChatGPT, and it will actually import. In this file, in the JSON, anyways, you have the property set. Okay, so these will create the property set if they don't exist. So don't worry, you can just add the parameters to the property set, and you will add the property set. Okay. So let's keep moving here. I'm not sure how many Rhinos I opened. Okay, another one. Perfect. So we have imported, exported parameters as we wanted. We can create them manually using the interface as we wish. Another nice addition that we have now is also, of course, at any time you can also rename the property sets. Okay, so you can go here and edit. So if you make a typo, you can just data2 and change. So and at any point you can rename them. This is a new addition, and maybe we will see that a bit more in detail later. Scheduling. So we have this data. How we see this data is also important, so we can see what is in the file. So with the quick Q button, the old query, this is a brand new interface we have created recently. And so we can save schedules in the file. So at any point, you can just open a schedule and it will recalculate the data and display it to you as you want. So let's create one. So let's create, I call it test. Okay, so as I click it, now I have all my parameters that I can add to my schedule. Let's add all of them. Okay, I can also change the order of the parameters. So for example, if I want type mark to be lower or higher in my scheduling, I can do so. I can remove and add parameters as I wish. Okay, then I'll press OK, and it will show me all the family instances in my file, all the parameters that I have associated, also maybe category and so on. And I can change it here. So for example, if I made a typo or I forgot also to add this is a schedule, I can change parameters. Okay, I can go back as well We have an undo redo functionality. I can see all the values and start modifying them. I can quickly search every header for specific parameter values and all the modifications that you will expect on a table. But not only that, for example, let's add more instances of these blocks so we can have more things to look at. Okay, so if I go to Q, now you see my schedule is saved in my file. So as I open it, I have my data updated with the latest model information. Then I can say, okay, let's add a filter. So I will go maybe a bit quickly here, maybe Chris, because we can go very in depth in this. Maybe we cover this tomorrow a bit more. But I can create a filter, either and or, and start querying some parameters. For example, I want to say that the new parameters has to be greater than 170. Okay, by doing that, it will hide any parameter that does not satisfy that filter, and I can add also more parameters. For example, let's say the category equals generic models, and also maybe add a filter where the comments contains 1. Okay, so this will actually show only the things that are generic model and have comment 1. So we can add more filters to filter out the information in our file. We can also group things based on parameters. So if I click on groups, I can then group, for example, by family. And this will group all the generic models, module, and block 1 into one row, and you can see the count. So we have 5 instances of the block 1 family, and if I change here, I will change all the values of those instances. So it's easy to group objects based on parameters. I can group by several parameters at once, so I can nest and nest and nest information. And as always, if I save, when I open it again, it's back to this. Okay.
And the scheduling, it was added, right? When have you added this feature, or it was always there?
It's a new feature that is coming with a new version. So we had just a very basic table before. Now we have full-on scheduling capabilities, grouping, filtering. And one feature that we really like is the conditional formatting. So we can add several rules for coloring objects. So for example, I will add one that will say if my new parameters is 150 is green, or maybe if my new parameter is greater or equal than 200, I will make it red. Okay. So I added now these 2 filters, and as you can see, it will color the parameters based on that, and I can add as many formattings as I want. For example, I can also say maybe my family is block. So once you assign these parameters, maybe and this is very powerful if you're working with Grasshopper, because you can really add a lot of data to your file, but then quickly you can visualize your Grasshopper added data with the scheduling, and you will get all the conditional formatting, and you can even export into Excel all your data. So you can actually
great work. Yeah, I can see lots of use cases that I can use. Of course, it's hard to imagine when you're just saying like the blocks and information like comments, but if you're thinking about like a structure, so there's lots of things that you can check on all the structural elements, and especially if you have some IFC files, I would like to manage or make changes. That is great. In the meantime, we have one question, so if we can answer that one. When I select or change the IFC class, will I get a list of standard IFC property sets and their properties? So Ali asked about like Pset door common and door base quantities.
Yeah, so we don't include any default set, and we are not very aware that these exist. So you might need to create your own, let's say, template file with your requirements, and then you can add them to your file, as we said, using a JSON file. So that would be the best way. So we don't include any default values other than the default, type markups as I showed before. So for any customization, you might want to create them first manually or with Grasshopper and then export the JSON, or create directly the JSON and have all your default property sets and parameters in your file very easily with the import that we showed before. I hope that covers your question. So just to continue, so we have this, fine, perfect. Also, just to say, you can also find the objects. And as a hint, next version, you will be able also to color objects in the view based on the parameters. So the conditional formatting will be applied to the view, not only to the table. So you can actually even visualize very quickly without having to necessarily use Grasshopper to do so, because you can, but just to have a very quick way to just open a schedule and maybe color things based on that value after you assign the data. Let's do one export, manually export, and then I will go through maybe some all the IFC nodes in Grasshopper, so we can redo the whole workflow in Grasshopper. Okay, so I will select this data, and then I can click on IFC export. Here, a few notable important things. We should have 4 hours probably to go over everything, but I'm using internal origin. Internal origin is the geometrical origin of the Rhino file. If you want to export with another origin, you can. And actually, we do recommend you model your geometry close to the real geometry 0 of the file, and then create a custom C-plane to represent the IFC origin. So it does not create a lot of the geometrical issues you might have when modeling far away from the origin. So, for example, to do so, I can create a C-plane. Okay, I will place it far away, maybe from the geometry. And then I will go to my named C-plane and save the current C-plane to survey, or maybe World Coordinate System, WCS, whatever you want. Okay, so now this is my origin of for my IFC, but this will be my geometrical origin. This is very good because try to not model in world coordinates. It causes a lot of issues. You can always export in world coordinates using a C-plane, which is just metadata. It's not really, it's a calculation the software does, and so it will not break a lot of meshes and blocks and stuff. So it's important that I save it as a named C-plane, otherwise it will not appear. So let's select again everything. And then we go to IFC export. And now I can pick WCS as my origin, okay? And then pick the IFC version. I will use IFC4 now for this example, but you can choose anything that you want. Another thing is that with this button, IFC settings, and included also here on the panel, we can also access some other information that is important in IFC. For example, the file header, okay, with description, author name, author email, all the values that you must insert. Of course, application name and version number is read-only, because that's how you're exporting your data. So you can change the header of the file. You can change the address of the file. Okay, so we can set all the properties for that, including the actual address, and maybe a few other information about the building and site. Of course, every Rhino file will be one building only. Okay. In project info, same. So there is also site description, which is slightly different from the address, but that's how IFC does. Address will be the postal address if you're more into the IFC schema definition. But in the project info, we have information about the building and the project itself. Okay, so now this is what we have set in our file, so it's very easy to add. All of this is also changeable in Grasshopper. Okay, so I'm happy with the settings, and so I will just click OK, and then in my desktop. The Rhino file is by default the IFC file, but you can choose any file, any image you want. Okay, and then in a few seconds, it's exported. Let's see the results of this file with Vision.
In the meantime, Alexander just wrote that is a very nice tip with the C-plane, and I also can say that because this is one of the biggest issues with IFC, the wrong coordinate system, and this can be solve the problem, and it's quite easy in Rhino. I know that in Revit is the pain, real pain, but here it looks really easy.
It's as easy, but it looks more difficult. In Rhino, it's definitely no-brainer. It's so easy to set as a coordinate, but it's the same workflow. And all of this is also available when importing. We'll see that as well. Importing FC is the only thing you cannot do with Grasshopper. That has to be done manually. But exporting, we can also automate exporting objects from the Rhino file. So let's just have a look at the results of our export. So if I go to
don't know, so there is no any workarounds how to import. You have to put it.
As of now, yes. As of now, we don't have it. We might add this feature in a coming update. We just have the export now in Grasshopper. So if there is request to import automatically, we might also add that. So it might be in the 1.13.1. So just wait a few more weeks and maybe we will include it. So as you can see now, I have my project. So by the way, this BIM Vision is a good software, it's free and opens IFC very well, very fast. So I have my project, my BIM demo. As you can see, I have some descriptions. I have the some schema information that we have added before, and then we can go to the site, and it's London, City of London, all the information that we added, including the location, properties, and we have our building. Okay, so everything is nested as kind of ownership. So BIM, etc., and we have also our properties that we have added, and then 2 levels, which are the 2 levels we have created in BIM. So if you open here, you see level 0, level 1, and so we have now level 0 and level 1 with the correct height in millimeters. Okay, and as you can see, as I select things are associated with that specific level. So in level 0, we have our piles type object. That's the IFC pile category or type, and then we have our instance, and then you will have the parameters that I have assigned. By default, we strip away empty values. That's a more standard way of exporting IFC, so we don't include empty values, which are also convenient. So if you leave something as blank, you will not have that information. So we have our area parameter with the units, our information, the Grasshopper is cool, and then our true or false parameters, and same for things on level 1. So I have 4 instances of our pile. Each one will have a different information. In this case, just a mark because comment 1 was the same, and so on. So everything was exported correctly in our file. Okay, so I hope everything is clear so far.
Yeah, everything clear. We have one more question from Afonso. And again, thanks for all the questions. If you have any question, if what is possible with the IFCs, just go in the chat. We'll have time afterwards to answer all the comments. Is it possible to retain object names from Rhino, but with multiple objects instead a family, or the data system is completely parallel?
It's not sure if I understand the question. If you want to rephrase it, Afonso. It's possible to retain object names from Rhino, but with multiple objects inside a family. So as you can see, all of these objects are inside a family module, if that's the question. And in fact, in BIM Vision, they are part of one piece, called the module. What is it? It's under
so in Rhino, it's like a object, right? And it has to be as an object, or it can be as a just BRAP or surface?
No, these are all surfaces and BRAPs. Any object in Rhino, any type of object, so both sub-D, BRAP, or normal surfaces are available, unless you can also create a block. So either blocks or, as we call it, loose geometry. So geometry not inside blocks, but any geometry in Rhino is available for that. Just curves and points were not exported to IFC as of now.
So for example, in this case, if I would like to have this railing, this barrier on the top, let's say that is a barrier here, the glass barrier. If I would like to set different properties for just this element.
Yeah, I will have to call it railing.
Railing, okay.
Into railing, so it will have its own set of parameters. Okay, so for example, if now I export again everything as world coordinate, then I overwrite this file. Okay, and now in my BIM Vision, it will probably ask me to update the file in a second. Sometimes okay, yes. Okay, now this is a separate railing object from this. Mm-hmm. So you might want to create different families for each piece or different blocks for each piece of your file. We are working on nesting in IFC. Is a little bit complicated how we would manage that. So we might unlock nesting of blocks to create subcomponents, but not all the viewers visualize them very well. when you have nested components, so they might explode them anyway. So we are still investigating how we could make that easier. But the easiest as of now is just to create 2 separate families for each piece, or different block instances for each part of the project, if that's the question.
Yeah. Just let us know, Afonso, if it answers your question. One more. Is it possible to have an assembly instead of a mass?
So we are not supporting assemblies as of now. We can import assemblies, although they will be exploded in blocks, but there is no native way to create assemblies, IFC assemblies of now.
That's okay. Let's continue.
Okay. So let's go to, actually, let me think about what we could do now if I will use a file or not. But let's open Grasshopper and have a look at the Grasshopper part of Beam.
Now let's start. Fun begin, right?
Well, yes. It's very simple, very easy. So there will not be crazy scripts, but I hope it will be interesting. So as you can see in Beam, we have a bunch of nodes, components. Let's call it. Available for different areas. We kind of color coded them, so more IFC related information would be the purple, and maybe blue is basic data from Beam, and green will be blocks. So we added some functionality also to be able to select blocks, as it is at least in this version of Grasshopper not native. And you can also automate export. These are for Revit, so we will be looking maybe at export IFC first. So let's open actually a file I have here for the panels. Okay, open. So I have this file here. It has some geometry, maybe nothing crazy, but we have a lot of panels that we want to be able to automate the assignment of data. Okay.
Mikael, if this geometry is not crazy, I don't know what kind of structure you've been working with.
Oh, well, I'm sure your students are capable of more cooler designs. Okay. So
it's crazy. It's crazy enough. It's crazy enough.
It's crazy enough. Okay. So let's open actually. I know this is not the correct one. Sorry, that's okay. CSS parameters. Okay, these are ready done script. We can go through that, or I can go one by one. Not sure what would be the longest to say, but we require data to be baked. So let me actually delete some of this information here. Perfect. Okay, perfect. Just cleaning out the data. So I have these panels. They don't have anything associated with them. Okay, just surface geometry. So first, we will reference this information by using the geometry referenced node. It must be baked geometry. If it's not baked geometry, all the data assignment nodes will bake the geometry, but they are, let's say, smart baking. So as you change the Grasshopper script, they will rebake the information. We can do one from scratch just to show that. But the idea is that we are creating some naming system. So we just name them in sequential order. So from panel 0 to panel 99. Okay, so we concatenate the number of panels with the names. And then we also want to assign some parameters. So we are using the set object parameters node, and these will assign information to loose geometry. If these were blocks, we will use the set block parameters or curve and so on. So by doing that, we can plug the geometry, which we have referenced from here. We can assign the family name, and these will be the family names. Okay, so panel 0 to panel 99, all flat. Then we can assign a subcategory if we want to, a material, so glass or metal. So now let's actually recalculate, recompute. Okay, so as you can see, now the glass was assigned to it. I can also change it to metal, and it will change immediately. So I can change my material. Okay, bake is not important here because this is not Grasshopper geometry. We will do some Grasshopper geometry, but we can either leave it as it is with a toggle. So you can have a toggle here set to true, and this will automatically bake as we change the geometry, unless you use a button or set it to false just to block the automatic baking. Okay, but this, since this is reference geometry, we don't need that. We can ignore this. We can also, while baking, we can also assign it to a layer. Okay, and if the layer does not exist, we'll create a layer. So these are two specific for Grasshopper geometry. We can do an example later, but now we're working with reference geometry. The idea is that now we have associated the family name and the class material to all the parameters. So you can see now we have created correctly all our paneling. So you might use your own workflow to add the correct name, but we can do so from reference geometry, or if you imagine this is Grasshopper geometry, we'll be doing that the same. So if I change maybe this from framing, I can do that, and it will immediately update to framing 98, etc. Okay, so let's actually go back to panel. Okay, so now it's panel 98, etc. Hope I'm not going too fast. So that was the first layer, assigning the families and assigning the material. Next, we can start adding some parameter values. So here we are calculating the area of each individual panels, and then we're getting here all the area values. Next, we just have to identify a parameter name. Okay.
You can just show what component is that, because it's a new component for Rhino 8, like with data change, source and target to the left.
Since for
to change the units. That
exactly. Since for each panel we need one instance of area. In case we have multiple parameters, you can also plug just one parameter name, but we want to duplicate this area for each parameter, so we can associate these as a grafted list. So area, because each panel will have one entry, and then all the values here. And then we use this node, which is the set family parameters, okay, which now is purple, but this should be blue. We changed this recently. So if I unblock these, if I enable this, have a look at the panel, because it will change in real time as I have one thing selected. So if I enable it, you can see now my area in millimeters has been applied to the objects. So this is as I change my geometry, it will populate automatically my area value for each individual panels. So let's click some other panels, and you can see the area is instanced on each panel type. Okay. Then we also want to add some type parameters. Okay. So in this case, I already have created the parameters in the file, but I will show you also how to do that with Grasshopper. But I know this parameter MKS, parameter name manufacturer, already exists and is a type parameter. Okay, actually instance, but let's change it to type. I prefer in this case. So the manufacturer is a type, and it's text, and is already in a Pset. So now let's enable it. And very simply, you will add my manufacturer MKS to all the panels. So all the panels will have the same type parameter. Okay, and I can change these to any other value, and it will update immediately. Okay, so let's keep it as MKS. We can do one from 0 just to show the workflow. So we have added some instance extracted parameters from Grasshopper, which will be the area. Then we have some unique parameters that might be common to all or not, but maybe text parameters, some values that are not extracted from geometry but are calculated some other way, or are fixed values. Okay, so we use the set family parameters node here. And then we can also set the category in either node. It's fine because we're doing it twice. This could be all combined into one, but we separated them. I would think it's easier to just work separately. The category node, which you can find in document categories, it's a bit maybe complicated. If you right click, okay, you can plug here any name in string of these values, but you can also right click on the icon and you'll be able to choose, as you can see, lighting fixture. So as they change the value, it will update my selection value. So I think it was a structural framing. Okay, so it's very easy. Just right click on the icon to show the list.
Thanks for sharing. Thanks for sharing this tip, because it's not
super
not that
easy, but
not super clear to see it. But now I can tell it's much faster.
Yes, you can also just plug generic models. So you don't have to use necessarily this. It's easier to just not make typos, but you can also type just a name as you see here in the dropdown, and it will work. Because we're not happy actually with the IFC data type, we also take the same families. So we're always using the family name to assign the parameters. So we just need the family name here. We will share, of course, this script. And then we have the set IFC family parameters. I think these are reverted colors. I apologize for this in this demo. So as we enable this, it will change this area, the IFC data. So we're setting everything to be IFC covering, or maybe you can change to IFC member if we want to. Okay. If the predefined type is not correct, you will not assign that. Okay. So we'll go to not defined, because cladding is not part of IFC member. But if I do IFC covering, it will do. And I can also change the description live. Okay, so if I press OK, you can see these changes for all of them. Right? And so it's very easy to change parameters. So this was one example. I wanted to cover this very quickly, then we can go maybe one by one just to see all the nodes, how they work. But then we take all of these families, all of the geometry, so the same reference geometry, we plug it here in our IFC export IFC component, and then we have our selection, which would be the objects. This name might change to objects in the next version, so be aware of that. So we have our selection, which would be the objects. They must be baked in the file, or it won't work. So we can only export existing information. So we need to bake them in the file because they have to become the BIM objects. Then we have created for each panel a path for an IFC. Okay, so you can export all of them individually. That's what we want to do. And then we can select a plane, and this will be like using the C plane. Okay, so you can put any plane, and these will be used as an origin. So similar to when you export, you can select these. In this case, it will create a plane in Grasshopper, and it will use that as your origin. If you leave as it is, it will be the word 0. We can choose the scheme as well. Okay, so if you right click on it, you can choose from this, or you can plug this exact text and you will lose it. But the easiest is just to click on schema and say, okay, I want 2.3 or IFC4. So, and two ways of exporting. This is because some people asked us to do it in a way or another way. So you can click on the button, or you can plug a button to the export. So either one works the same. So if I click on here, you can see it started to export. And in this folder, export panels, all my FCs are slowly being populated and exporting one by one. Okay. So while this is continuous, I will already open a few of them just to see.
This is really impressive. I don't think so that any software has these features. Of course, we have some converters, but it's really cool because sometimes, like if you would like to export some facades, some elements, so you have to do it one by one, and if you can do it in the bulk, so it's really amazing.
So you can see now one FC as an example. Maybe I can open another one just to have more in the file. Actually, I have to do add file. Maybe we can add more. Okay, this viewer does not. So I have added 2 different IFC files, and each one will have would be a space. See, can be those are 2 individual IFC files. they have the area, they have the manufacturer as I wanted, and so on. So you can do a workflow like that, or export all in one go. You know, up to you. Depends on your needs. We have seen we have some issues where it was required to export one IFC for each structural beam element for fabrication or for checking, and so this was required. But let's maybe this was kind of an overview of one example of workflow. But let's go and have a look. If we start from scratch, let's open a new file as well. Okay, so let's say we have a sphere. We'll try to have everything visible in one go. Might be a little bit difficult because we have the panel. Well, that's fine. Okay, for example, if I make a sphere, my file. Okay, now this sphere, I want to have it in a family called sphere. So I will say set object parameters. Okay, I would, before actually clicking on it, I will also add it to my level IFC, and then double colon test. Okay, this is the usual layer path. So I want to put stuff in this one, and then maybe a toggle as true. Okay, now I can plug my geometry. Okay, so now you can see it is baked in my layer IFC test. Okay, so this sphere is in IFC test. You can see here. As I change the radius slide, let me do a slider. This might be a little bit small. Let's see how it is. Okay, as you can see, as I change it, it's already automatically baking the geometry. Actually, I can turn off the preview. So it's automatically baking the information. If I set it to false, it will not do it. It will just update the Rhino preview. Okay, let's actually do. Cannot see. Maybe the eye is smaller than everything. Okay, now you can see. But if I set it to true again, it will bake it. So that's a auto baking functionality that we have in all these set objects information. So by the time your users know the objects will be inside the file. Okay, let's click it. So there is no family assigned to it. So let's start doing that. So I'll say this is my sphere 1. Okay, plug it. And now sphere 1 is there. And I can also assign it a material if I wanted to. So let's create a material. Okay, so we just need the name of the material. Okay, class. Of course, it's rebaking, so I have to reselect in this case, but I can also set this to false. Perfect. So I have my object properties set. Now, in the same using the same family. Okay, maybe I can. That's fine. Now, this is for my geometry. Now I want to add some parameters for the family. So actually, let's go to set family parameters. I plug the same family. If I want to change now the category, so I will do category and pick furniture. You can see this changes immediately. But I also want to customize the IFC family parameters. Okay, so I plug the same family. And this type I will type the IFC covering. Okay, and now if you go here, IFC covering is set. So it's very fast to do that, and every time I change, things change in real time. Okay, so I can check the models. I will leave predefined type as it is. Then let's add some parameters. Okay, and they will go always in this list. So let's see if I'm not super rusty with Grasshopper, but I want to create some parameters. So go to documents, and we have some nodes, create or edit parameters. Okay, so first I will create maybe a parameter called manufacturer. Okay, so this will be my parameter. So I have to put all of the data. So instance should be true or false. So say this is a instance parameter. Type, I will say this is text. It's fine. So So we use type text. And then we need to add some categories. And these, I would just say, this could be also a list, but maybe let's do two. Maybe better ways to do this, but I'm not super furniture. Okay, and then merge. Let's merge all of this in one list. Okay, there are many ways you can do that, and probably Chris, if you join his classes, he can definitely help you to be better than me at this. So, but as you can see, manufacturer now is added, and if I go to my P, manufacturer is added as an instance and text parameter. But if I change these to area, it will immediately change these to area. Okay, so I can create or edit parameters using this node. Okay, so I created a manufacturer parameter, and now I can actually, maybe we can create two parameters. Let's create another one that we'll call classification, or maybe scope or phase. Okay, it's called a phase parameter, always text, and available to just generic model, for example. So I can just do this. And I have my phase instance and text parameter added to them. So you see, I haven't added a property set. So let's add some property sets as well, which here are called parameter set, but they might change. So let's say pset 1. I will add this to pset 1. As you can see, it's already added. And then let's create pset 2 and add that to that one. And it changes immediately. So you can see this is added. Now we will assign those two parameters using the, not the IFC one, but the family one. So we have just to have, can use the same panels, or just copy them and reuse them. Okay. So now this is where it might be important to take care. So the grafting. So let's say that one is MKS1 and the other one is MKS2.
Data trees, most complicated aspects of Grasshopper, right?
Yeah, exactly. So now we have just, actually we have one sphere. Maybe let's create another sphere. Well, this one, well, let's assign just two values, one manufacturer, and the phase will be phase 1. I think I have another example that is ready that may be better than me starting from scratch. But the idea is that each one of these should be grafted for each object. So for example, I merge this. That's the way we have done it. So I will now we'll just show the easy version, and then we will open a more richer the superscript with more parameters just to see what happens. Okay, so also I can merge these two. Okay, the idea is that for each one of these lists, you might have one of these. So if in case there were more objects, just kind of create, make an example. I think actually maybe it's easier if I open the file. Let's just assign them like this for now, and then we move to another file when it's ready. So first the parameters, sorry. Okay, so we plug the parameters here and the values here, and you can see it populates. So very easy. But for each object, you want the list of parameters. This can be flat just once, but then for each one, we need a grafted list. For this, we'll open the example where I showed it. And so very quickly, I have created and added more values. So maybe I can add more. Once you have this set up, it's quite easy to add more. So for example, let's add a comment. Let's add a comment 1 value. So if you plug this here, of course, you will say, so we added a few securities to say if you're missing one value and your listing is not perfect, we will warn you. So let's just add this and it should correct. So comment 1 now appears and I can change anytime. Okay, so comment 2. So we can add all these values. Okay, so we create the parameters, assign parameters. Let's also create some levels. Okay, so of course, now we just have one sphere, so it's not important, but we can also go to levels. And there is a bunch of nodes per level. For example, we can create one by name and height. So you can say this is my level 1, and is at 1000. Okay, our file is in meters, so actually let's put 2. I plug it, and it creates a level. If I leave the name, it will actually edit the level. Okay, so no worries. This is create or edit. You can also remove levels, etc. We can also, and this is very useful, I will do this example. We can find levels also by closest height. We'll find this, so you can avoid creating some complicated scripts. If you have the Z, we can give you the closest below level in case you want to assign objects. Yeah, you can also get the list of levels. I think there is a lot of nodes here to explore, but we can go one by one like here. So now we have created some levels. We can assign the level to this object as well. Now it's in automatic, but if we want, we can go to levels. And this is the distinction. If it's loose geometry family, so as we said, geometry not in blocks, you might want to use assign level to family, and this is the case. If it's inside a block, we might want to assign that to the block itself, not to the family, because we assign it to the instance. So let's assign a level to family. So for example, so this is sphere 1. Okay, so this is my family. And then let's find the level, actually. We have the point, is the base, no? So let's actually do, I'll actually draw a point here, point, sorry, point. Let's get a point here, and now point. I'll select this point, select one point. Like this, select set one point. Perfect. If we move this point, it should be fine. I'll use this as a base. Okay. So in theory, okay, when I bake, as you can see, if I move the point, the sphere moves. Okay. Now I have two levels, at 0 and at 3 meters. Okay. Now this point, I want to find what level it should go to. So I will go to levels and say get closest level by height. Let's evaluate, actually deconstruct, take my point here. Okay, so I have a Z component, which is now 6. Okay, so if I plug it here, it will give me a level. And it says that level 1 is the level closest below this value. But as I move the point, maybe I have to go to ghosted. I move this point lower. Now it says level 0. So that's an easier way to say, okay, whatever point I'm considering, give me the level that is below that. And if there is no level below that, you will use the closest, the first one above. Okay, so if we go below the level, okay, it might give you different values. So
okay, I just sorry to interrupt you. We have one question, okay. And maybe after we will jump to importing, or would you like to show something more from?
No, I think to show the last thing, we have assigned now level 0 to the. So with Grasshopper,
yeah, so
all these workflows. I hope that's
just jump to it, and let's afterwards we have question, and we can go to import. Okay.
Okay. So. Yeah, there's not much to cover. Of course, we can also change other things. For example, we can set the address of the file. Okay, there's a lot of information we can do. So we can also change the location of the file and the header. So all of these IFC data we can do. Change level, as we said, a bunch of creation and assignment of level, or finding the level from a height, or maybe extracting from the block, and then we can read and write object and family parameters very easily, okay, as well as in the document, creating and deleting parameters. It's also easy to get a list of parameters. For example, if I plug a category, I can get also what parameters this category have. Let's do generic models. Okay, and you can see it will give you maybe the parameters of that category. So you can extract them from the document or create them yourself using this tool. Yeah, I'm conscious of time. Let's show a little bit of an import. Also,
just one question before that. For freeform geometries in Revit, maybe we're going to show that in tomorrow workshop more. Is it better to use adaptive components or generic models? Which approach provide a more flexible? What is your recommendation here?
We might cover that more in detail tomorrow, but it really depends. Adaptive components are great, we love them, but they cannot do all of the freeform shapes, ensuring also continuity of the geometries, because it's only interpolated surfaces you can do, and so you don't have control on curvature as well as you have in Grasshopper, in Rhino. So depending on the shape and the geometry, you might want to use adaptive components that are very good, but other shapes you might not want to do that. So maybe we can, because you have this question, we can have a look tomorrow. But there are many use cases for both, depending on the shape of the geometry.
Perfect. Okay, let's go to importing stuff. How we can IFCs into Rhino. It's so easy. It's so easy as we did it with exporting.
Yes. So as we said, we might want to add a node to automatically import with Grasshopper, but it's it might not be exactly what you need to do. You can just go on IFC import, and let's take the same IFC we exported before with Beam. And there are a few settings we can set here. One, and we like this workflow, we automatically link it as a work session. What it will do, it will create a 3DM file in the same directory where the IFC file is, and it will add it as a work session to your file. So you don't import all the geometry in your file, but you can still access it and all the information. So let's pick a better file. So if I go to our folder example, that we will share with you, okay, import IFC. So let's pick architecture. This file is a 2 MB file. I will choose to have it as a work session, not import spaces. I can also decide to import it using another C plane, as we said before. But importantly, we can also, and this is some viewers and importers don't do, we can also, or maybe this we can turn it off, we can also decide to not import certain categories. So let's uncheck this so we can see what happens if we do. And then this is a Rhino specific thing. If we want to merge coplanar mesh faces, so the meshes look a little bit better in Rhino, we can also decide to keep all the vertices as they were. But this is a kind of a graphical thing. It will not change the mesh really. We just change the representation, but it takes a little bit more computing. From our testing, is very little computing, so we might want to have this on. But to have the proper triangles visualized as they were, you might want to turn off this feature. Okay, so let's do it. And it parsed the IFC and it says, okay, in this IFC, you have these categories. Which one do you want to import? All of them or some of them? Maybe you are not interested in having the walls imported, or you just want the walls imported because for your work, that's what you need to import. Now, of course, we will have everything imported. Okay. Now press OK. In a few seconds, it will create. You see, in my folder, in the same folder, we create this 3DM file. And now, if I go to work session, sorry, it's another screen, it's already added in your file as a work session. So if you want to link an IFC file, that's very easy. You don't have to import it in a separate file and then work session yourself. We allow this immediately. But you can also decide to import directly. We'll do that as well. So now this is a work session file. Okay. And first, let's see the layers. So you can see our duplex here. We have, we add all of the IFC subcategories as separate layers, so you can turn them off and on if you want. So walls are already walls. So just for convenience, we have added every single object in a specific layer for the category. And then using the beam panel, if I select something, you can see the IFC data connected to that object. Okay, so including the category and the parameters if they have some parameters. Okay, so now there is a bit of let's hide. If I click on here, you can see now this is just a random IFC file that we have laying around, but you can see all the metadata connected to the object from the IFC file, and this is a work session file. So as I click them, I can still access all the information. They're not editable, so you cannot edit them, but you can copy paste and use them. Okay. So you can start adding more files. So for example, if I want to link also the other information, so let's say import FC, I will also add the mechanical as a work session. Okay, import all the categories and so on. Perfect. Now I have my mechanical also added to my file, and this is part of another properties, another work session file. Okay, so I can turn it off or just turn on the things, the MEP, and as I click them, I have access to all the properties, okay, that were included in that IFC. So I can use them in my file as a reference. Okay, so that's really easy and straightforward. Just for the sake of completion, let's also show how it would work if I would import in my file. So let's say it's import, and then I will pick the MEP. I kind of like it. Sorry for all of these. Okay, so let's go to mechanical, not work session. Okay. Now this actually created the geometry inside my file. As you can see, all the parameters are now added to this document. All the parameters, including all the information. I can export them if I want. As I click, is the same, so I can access the information. Okay. This, because it's not work session, it will show also empty parameters. In this case, this IFC had all the parameters in all the categories, so it's a bit messy, but you can modify all the values and export again in IFC, and it also imports levels if there are. So you can see it imported all the levels from the IFC and assigned the objects to the levels. So let's have a look at the levels here, if they are. So this is in level 2. So we have also that information. And conveniently, because it's imported, we might unlock this functionality also for work session objects, but now they must exist in your geometry. You can also schedule. For example, maybe I want to have a schedule just with the categories. So create a schedule with only categories and maybe the family name. And then group them by family and group them by category, for example. Now I have, or maybe I want to just not group them by family, but just by category. I have everything is in generic models, so might not be useful. Next, I can, sorry, close it. I can maybe add the level information. Okay, so now this will have level, of course, is in various, but then I will group first by category and then by level. So let's pick level here. It's one of the built-in ones. Okay, so you can see now I have 200 objects in automatic, so with no level assigned, but then I have 97 on level 1. If I click find, I can see all of the objects that are assigned to that. So as you can see, I can visualize and query all the data from my IFC file using the schedules tool as I want to. And of course, I can modify the built-in values not, but any parameter if I bring it up. For example, let's bring adapter length. And now I can say this is 150. And this will actually add the value and modify the value. And you can export this IFC again and have it similar as it was before. Okay, I hope everything is clear.
All clear here, so you can continue. Is it also possible to change it with Grasshopper?
Yeah, every data is changeable with Grasshopper now, as it was before. So, for example, let's create a new document. Now, if I go and get, now these are probably blocks, so I can list all the blocks. Okay, so now you can see these are all the blocks that were imported, which are basically the instances. We must append an ID because, of course, Rhino does not allow to have different geometry in instances of the same block. So these are all the instances. Might look messy at the top, but you can see you have all the pipes. But then we can start getting some data. For example, we can find all the blocks by name. Okay, so we plug the names and we get our list of blocks here. Okay, so I have all my instances for each family, all the instances. Okay, then we can get, for example, the parameters. So we plug not the panel, so we can plug it here, and now we have all the categories. Sorry, all the categories of these blocks, and importantly, the parameters. So these are the parameter names, right? And these, sorry, and these are the parameter values. Okay, so you can see. Hopefully this is clear. I will enlarge it a little bit. So as you can see, I have it's a lot of parameters, but for each one, I have the values. Okay, and I can use that. But not only reading, I can also write. So if I take the same blocks, so it takes the same blocks and I add parameter and values, I will be able to change the parameter and values and then decide to export them singularly or select a subset of those and explode them, move them around. So all the metadata is accessible with Grasshopper and importantly modifiable.
And what about geometry? How can I extract geometry from this block?
So
like a BRAP, how to get a BRAP or surface?
The new Grasshopper might have nodes, but until we wait for those, we have also some. We don't have editing capabilities for blocks added here yet. You might find other packages that do that. But if you want to get the geometry, the definition geometry, not the instance geometry, you can have it here. Now it's gonna probably crash my Grasshopper. I'm not sure this is a good idea. So let's just because it will be thousands of blocks. Let me just take this.
And maybe here. You can just take a list, just one block.
It's 25
as a last item. Yeah,
that's fine. We'll just do this so it's easier. Cherry pick, I think it was cherry picker. Okay. Now I have the mesh included in the, so you can access the geometry if you wish to. This is a definition geometry, so it probably will show in the center of the file. Okay, as with any block, the instance is in a transformed location compared to the definition. But if you create a block or modify the block with other packages, this will just work. We just need the instance here to be able to modify the metadata. So in any way you want to modify that with Elephant, I don't know, some other packages you might want to do. I think Rhino in Grasshopper, maybe Chris, you know more, they will have more nodes for blocks coming.
In Rhino 8. In Rhino 8, it was added as you showed like this called Rhino. So you can just add it and extract more data.
Yeah, so you can do here a lot of stuff. You can explode or model a block instance, but also I think in Grasshopper 2 there will be much more things. So you see how I can query the data from an IFC file in Grasshopper.
Perfect. Okay. Thanks for that. Would you like to add something more to?
I think I guess everybody is tired in the meeting. I'm also starting to feel it. So if you have questions, now is the time, so we can go maybe into some specific things, particularly with some questions.
Perfect. Thank you very much. Great presentation. And yeah, lots of possibilities. Like I see great improvements since I last downloaded. The latest version I downloaded just a few months ago, but I see already how much has changed. So great work. Mauro, would you like to join our conversation for the questions? You can just so let's jump it. Okay, thank you for sharing. Let's jump. If there will be some questions, I think we already answered most of them. But if you still here with us, so please ask some questions. So we will hear, and we will for sure tomorrow we'll have more time. Let me see, I'm going for plan. So today we went through assigning BIM data. This is from levels, property sets to Rhino objects, controlling IFC exports, naming Psets file structure, importing IFC back to Rhino and keep it organized, and automate with Grasshopper with the flow. So yeah, so that was good plan. We went through all the topics, and today we will talk more about delivering everything in Revit. So we will take this question. So maybe we can also talk it further about adaptive components and generic models. But today, lots of good response. Thanks for the workshop. It was really interesting. Thank you, Mikael. Thank you for the answers. So yeah, good comments. We had also got it here. Let me just show you. BIM, great software. I use it, and it's an amazing tool for design and collaboration. So, guys, it looks like you made a great response. Thanks for the great presentation. Is it possible to export step files as well?
Well, IFC is kind of a step file if you ask a few people, but no, you just can export IFC.
Yeah. But you can export as it from Rhino, I think?
I think so, no? I think that's one of the export formats.
Andrea, thanks. See you tomorrow. See you. Alexander, great workshop. Very interesting. Daniel, thank you both for very much. Nice. Good work. People really like it. Thanks again for all the questions. Thanks for the presentation. And yeah, see you tomorrow at the same time. We will jump into, so now we know everything, not everything, but we know how to manage, how to change Rhino into BIM machine. So now let's jump into Revit and find out some great workflows. Again, thank you very much.
Thank you,
and see you tomorrow.
Thank you.
Everyone.
Bye.